In this unit, we're going to begin our discussion of solving trig equations. Today, we're going to solve using a calculator, which is going to be pretty easy, and then we're also going to solve some simple equations without a calculator. These are some that we could have done when we first started studying our trig ratios. Hopefully, we have a good grasp on those. We'll be reviewing those during this unit as well, just to make sure, because we kind of need to know those ratios and the basic ones for 30 and 60 and 45 and all of the ones that fall on our unit circle. It'll make this much easier if you already know them. But we're starting off with some that are just graphing calculator problems, and so it says use a graphing calculator to solve each equation. For x between 0 and 2 pi, it wants us to draw a sketch and to express our answers in terms of radians to 3 decimal places. So just a few things on your calculator. Be sure on your calculator that your mode is in radians. There is a way to graph some of the trig functions in degrees, but we're not going to be talking about that today, so be sure that it's in radians so it graphs correctly. Also go to your window. We want to set our window from 0 to 2 pi. So 0, enter, 2 pi, enter. And then our y's, I'm going to set mine from -5 to 5. It could be more or less depending on what shrink or stretch you have, but that should take care of most of our graphs. If our shrink or stretch, which is the number in front, gets larger than 5, then we might need to go a little bit bigger. All right, so that's it as far as work to do ahead of time, and then you just type your equations into y equals. So don't forget that when you're typing into the calculator the TI, it's going to open a parentheses. You're going to put your b value, which in our case is 1/2, and then I would separate the x. It really won't matter unless there's a shift left or right, but that's okay. I would just practice putting that x in its own parentheses. And then in y2, we're going to put the other side of our equation, which is 3. All right, and so now we're set to graph. So just graph. Uh-oh, and mine just died. Looks like my batteries are low. Hang on just 1 second. All right, so we're back. So here we go. Here's our graph from 0 to 2 pi. And here is where our answers would be, where the intersections are. So we're just going to sketch the graph and then we'll find the intersections. So in sketching our graph, we want to label that this is at 2 pi. Our line there was at 3. And we want to find these two intersections right here. So we're going to second calculate, second trace, 5, enter, enter, enter. There's our first one. So we're going to go 3 decimal places. This is in radians. So that would be 1.696. And then the second intersection, second calculate the intersection. Move over there close to the second intersection. And we get 4.587. All right, so what we did, y1, we put the left side. And don't forget extra set of parentheses there. And in y2, we put the right-hand side. And then we did second calc, 5, to find our intersections. All right, same thing on number 2. So just type this in the calculator and we'll find the intersections. All right, let's take a look at our graph. We're going to type left side in y1, right side in y2. And this one, it was x divided by 2, so you can just leave that. Put it all in parentheses. Hit graph. Not look right, so hang on. Oh, all right, there we go. This is supposed to be a cosine graph. There we go. All right, now then that looks better. So it looks like this crosses about halfway through, maybe 2, 3, 4, 5, 6. So maybe about 3, which would be a little less than halfway, because this is at 2 pi, and pi would be in here, and it looks like it crosses a little before that at 3. So the graph does something like this. And then we have our 1/2 going across here. And we want to find our intersection. Our solution is our intersection. So second trace 5, enter, enter, enter. And there we have 2.462. All right. Now for the non-calculator questions. It says, do not use a graphing calculator. So we do need to remember our trig functions of special angles, which is our unit circle. And we'll kind of go over that as we go through these problems. So this is a little different than what we did earlier, because in our other units, we normally had an angle in here, and we were looking for the trig ratio. We've done a few where we didn't know the angle and found other trig ratios, but not where we went back to find the angle. I think we only have one problem like that. So what we're looking for in these problems is the answer to this angle right here. So let's remember our sine ratio is y over r. So since it's y over r, they're telling us that y is -1 and r is 1. And in order for that to be the case, we'd have to be on the line somewhere for y and r to be the same. Now the only place that y is going to be negative and r is 1, 0, -1, is going to be down here at the bottom. And so that tells us what our angle has to be. The only angle that fits that description between 0 and 2 pi, one rotation around, would be down here, and that's at 270 in radian measure. That's 3 pi halves. Remember, 1/2, 2 halves, 3 halves, 4 halves. So 3 pi halves. All right, so that's what we're doing here. We're looking for the angle. So in this next one, they have not left the cosine by itself. There's a 2 in front. So the first thing we want to do is try to isolate x like we would always do. And so we get cosine of x is -1 over 2. Well, cosine is x over r. So in order for x to be -1 and r to be 2, then we're going to be talking about a triangle that has 1, 2, and the other number is always square root of 3 in it. So we know that we are going to be dealing with a triangle that's 1, 2, square root of 3, or a 30, 60, 90 triangle. Now, in order for the placement to be so that x is 1, that means that the short side has to be down here. And this is what I'm talking about. You've got to know your ratios. You've got to know what these numbers go with. And so 1, 2, and square root of 3 are always our set that go together. And in order for x to be 1, we have to have the 1 down here in the bottom of our triangle. And if that's the case, this is a 60-degree angle here, or pi thirds is our reference angle. Now, in addition to that, we did the all students take classes. Here we know that cosine is negative. Cosine is negative. And in order for cosine to be negative, then we either have to be in quadrant 2 or quadrant 3. Now you can do that with the all students take classes. This one, everything is positive. Cosine is positive here. So a cosine would be negative on this side. Or you could just remember, if x is negative, I have to be over here on the left. So in one of these two quadrants. And so if I'm going around to this first angle, which we know has a reference of pi thirds, then we're going 1/3, 2/3. So x could be 2 pi thirds, or we could keep going, 3/3, 4/3, or it could be 4 pi thirds. So these are both solutions because we have two places where cosine could be negative. All right, so it's super important that you know these ratios and you remember this little shortcut here for determining where each trig function is positive or negative. If you don't know this part, then you're probably going to leave out one of your answers. All right, one more of these. It's a cosecant. So they're telling us cosecant is 2, or 2 over 1, and cosecant is r over y. Okay? So again, our numbers have to be 1, 2, square root of 3, but they're telling us that y is 1 this time. So if y is 1, x has to be square root of 3. That makes this a 30-degree or pi 6 reference angle. Now, which quadrants are we in? Well, it tells us that this is positive. Cosecant is positive. And cosecant, or y, is going to be positive in quadrant 1 and in quadrant 2. Or if you do your all students take classes, it tells you that all are positive here. Sine and its reciprocal, which is cosecant, are going to be positive in quadrant 2. So 1 and 2. So in quadrant 1, we just have the angle pi 6. And in quadrant 2, we've got 1 pi 6, 2 pi 6, 3 pi 6, 4 pi 6, 5 pi 6. And this is 6, 6. Remember, there's got to be 6 sections around the top if we are talking about a reference of pi 6. So 1, 2, 3, 4, 5 pi 6 would be our second answer. All right, so in this lesson, we need to be sure that we know our reference angle triangles. So that would be, we did the 30, we did the 60, but remember there's also the 45. We didn't have one of those here, but the ratios for a 45 or for pi fourths would be 1, 1, square root of 2. And remember too that those come out like sine of pi fourths is 1 over square root of 2, but we also simplified sometimes to square root of 2 over 2. So if you see something like this, remember that that actually goes back to just the 1, 1 square root of 2 triangle. So that may be helpful too, because if you see this as an answer, we don't have 2 and square root of 2 on one of these triangles. That came from 1 over square root of 2 being simplified or rationalizing this denominator. All right, so hopefully we can get some good work done with these, and remember all of our triangle ratios, because you're going to have to know those in order to do these without a calculator.